Okay, so now we're going to put it together a little bit, and we're going to talk about how to graph rational functions. We're going to revisit even and odd functions, and we're going to talk about some varying strategies to help us to figure out how to graph rational functions. Okay, let's revisit a little bit about even and odd functions. Remember, an odd function has point symmetry, where I rotate the graph 180 degrees about the origin. If that is the case, I do have an odd function, and algebraically that translates into f of negative x is the same as the opposite of f of x. So multiply the function by a negative or substitute a negative x. Either way, I get the same function. In an even function, the y-axis is my line of symmetry, so I have line symmetry as opposed to point symmetry. And if you folded the paper on the y-axis, one half of the graph would lie exactly over the other half. And algebraically, that translated into, when I substitute negative x and simplify, I end up exactly where I started anyway. When I need to graph a rational function, this is the order in which I tend to look at things. First of all, if I can simplify, I do. But then I look to see if I have y-axis symmetry or origin symmetry to see if they're even or odd functions. I do that by substituting negative x and seeing if things work out correctly. Then I find the y-intercept, if there is one, by substituting 0 for x. Then I look for the x-intercepts, if there are any, by solving f of x equals 0. Once I have my x and y-intercepts, I look for vertical asymptotes, which would be formed by anything making that denominator be 0. Then I look for horizontal asymptotes, if there are any, by paying attention to the degrees of the numerator and denominator. Finally, I try to plot at least one point between each intercept and the vertical asymptote. Sometimes I need multiple points. Sometimes they're kind of hard to calculate, but I look for at least one. Then I use the information obtained previously to graph the function between and beyond the vertical asymptotes. In other words, is it even? Is it odd? Is there anything else that could help me find the way? Since the best way of learning to do it is by example, let's work as an example. If f of x is 3x minus 3 over x minus 2, the first thing I do is look to see if I can simplify by factoring my numerator and my denominator. And in this case, I notice absolutely nothing is going to simplify. So I go and I look to see, is it even or is it odd? If I substitute a negative x, that becomes negative 3x minus 3 over negative x minus 2. That is not the same, so it is not even, and it's not the opposite because that would have to be plus 3 and plus 2 to be opposite. So it's neither even nor odd. That's not going to help me much at all in the future. Okay, so the next thing I try to do is find my intercepts. To find my y-intercept, I let x be 0. So I say y is 3 times 0 is 0 minus 3 is negative 3. And 0 minus 2 is negative 2, so that's positive 3 halves. So 0, 3 halves is my y-intercept, and that's not going to stay there. I forget I can't make a dot. Okay, then for my y-intercepts, I'm going to let f of x be 0. Okay. Technically, I'm going to multiply both sides by x minus 2. But in all reality, the only way you're going to get 0 for a fraction is if the numerator is 0. Since they said minus 3, I say plus 3. I get x is 1. So my x-intercept is right there. and that's not going to stay right there. Okay, so I've got a total of 2 points, and that's not going to help me at all with this graph until I figure out something else. All right, as for my horizontal asymptote, now let's do vertical first because that's the order we learned them. For my vertical asymptote, whatever makes that denominator equal 0 is my vertical asymptote. So x equals 2 is my vertical asymptote. Wish I had a ruler or even a straight edge that I could lay down. Okay, that's my vertical asymptote. Excuse me. To find my horizontal, it's all about degree. They have the same degree, so y equals the lead coefficient of the numerator over the lead coefficient of the denominator is my horizontal asymptote. Okay, so this is going to be a curve. Since he's bound by both, I can't draw it to save my life. But this is going to be a curve in here that's going to hit at 1, hit at -3/2, and that's nowhere near close. I'm going to try to do a little bit better. He's going to hit at 1, he's going to hit at 3/2, and he's going to approach that and without bound. And this one's going to come down approaching this side without bound. But I have nothing over here. I don't know if it's down here going down or if it's up here going up. I know nothing yet. So how do I figure it out? I find some points that are out in here. Pick 3 and substitute 3 for x. That is 9 minus 3, which is 6, over 3 minus 2, which is 1, and 6 over 1 is 6. So over 3 up 6, right there. Let's pick 4 and see if it works. 3 times 4 is 12, minus 3 is 9, over 4 minus 2 is 2. 9 over 2 is 4.5, so over 4 up 4.5. So this one is going to be a line, and I think that's going to erase. It's a curve going up through there and coming down through here. Not very pretty when you can't hardly see what you're doing, but I've got a better picture on the next slide. This is the picture of the actual graph. Now I threw in a few extra points because I could do it on the computer a whole lot easier than by hand, but this shows you exactly what we were talking about. The vertical asymptote, the horizontal asymptote, finding a few points on each side so that you know where to draw the curve, and then there's the curve.